What's up, everybody? Welcome back to the Comet office hours. It is February 2nd, Wednesday, February 2nd, and we're back with another epic office hour sessions as we're doing this series called Standardizing the Experiment. And this is what session number is this? This is, I believe, the 5th session in the series. And today we're going to talk about how to manage experiments like a pro. We've got an awesome cast on the panel today. I'm excited to get into this. We'll go ahead and introduce each one of our panelists and we'll get into questions. Those of you watching live on LinkedIn and on YouTube, if you got questions, go ahead and drop them in the chat and we'll be sure to get your questions. We'll also share a link right there on LinkedIn for you to get right here into the Zoom room if you'd like to join us and see all this live and in action. That's awesome, and you're more than welcome to do that as well. So let's go ahead and introduce our panelists. So our first panelist is a physicist and data scientist who loves delving deep into data to learn insights that may be hidden by noise. She's earned a bachelor's in physics and mathematics from Trinity University and has gone on to earn a PhD in physics, specializing in nuclear science and quantum chromodynamics from the University of California at Davis. Her favorite part of data science is all of it. She enjoys end-to-end project oversight, everything from designing and developing to testing and productionizing statistical data analysis pipelines. She's currently a staff data scientist at Astronomer, where she's building data and machine learning pipelines that help make Astronomer and Airflow even better data science tools and useful to increasingly diverse user types. So please help me in welcoming our first panelist today, a woman who is excited by decision intelligent data science, Dr. Shantana Tully. Shantana, thank you so much for taking time out of your schedule to be on the show today. I appreciate having you here.
Honored to be here, especially alongside the other panelists.
Yeah, I'm excited to introduce everybody here as well. So our next panelist has an obsession with automation powered by the conviction that most tasks can be automated. It all comes down to just finding the right algorithm. He's a former optical physicist who has built laser-driven particle accelerators, ultra-fast electron guns, ground and space-based LiDARs, terahertz lasers, and frequency combs. That stuff sounds super fascinating. He's made the pivot to machine learning in 2017 and has since been researching and inventing new algorithms. He's currently a research scientist at Google AI, where he's working on speech and language algorithms. Please help me in welcoming our next panelist, a man on a mission to build robust, interpretable, and generalizable machines that can make sense of our complex, noisy, and sometimes adversarial world. Dr. W. Ronny Huang. Ronny, thank you so much for taking time out of your schedule to be on the show today. I appreciate having you here.
Thanks for having me.
Our final panelist builds and ships machine learning at scale with immediate impact. She's a principal data scientist in the fintech industry, where she helps e-commerce founders' dreams come true by applying machine learning models and infrastructure at scale to power intelligent investing. In the past, she's also used machine learning to enhance the website experience of millions through recommender systems and improve the call center experience of thousands of customers via reinforcement learning. And if all that wasn't impressive enough already, she's also the founder of a profitable video game studio where she wears many hats, from the sole developer, narrative designer, producer, marketer, copywriter, and everything in between. Realizing that data science and game development are industries with no straightforward path to entry, she generously shares the tacit and hidden knowledge that's often only learned on the job through her blog, speaking engagements, and other content. Please help me in welcoming our guest today, a woman who is driven by using her experience in data and algorithms to empower real people, real products, and real businesses. Susan Shu Chang. Susan, thank you so much for taking time out of your schedule to be on the show today.
Thank you so much for having me, and I'm in really good company here.
Yeah, I'm excited, man. You guys are all so awesome. I've been following each one of you individually for quite some time. And, I'm excited to get into the conversation. We're going to keep the conversation super organic. So I'm inviting questions from and comments from those in the audience, those here in the Zoom room. I'm excited to go ahead and get into this. We'll go round robin style in the order that I've introduced you guys. So we'll start with Shantana, go to Ronnie, and then Susan. I just want to pick your guys' brain on what it's like being a data scientist at the level that you guys are at, like that principal level and above, and some of the challenges that you guys face with respect to experimenting with machine learning. So let's start by hearing about what a typical day on the job looks like for you. Let's go to Shantana first.
Hi. Yeah. So as Harp said, I am in the data science tooling space. So our product is not a data science application, but rather a pipeline orchestrator that's built on top of Apache Airflow. And we have a huge involvement in the data science community to understand what people's pain points are and what's needed. So my day-to-day includes building data science and machine learning pipelines, often end-to-end, and ones that is specifically showcase Airflow's strengths and data science best practices. Of course, I do some internal data pipelining and analytics type work as well. So for example, right now I'm starting to work on the data architecture that will enable our sales and customer teams to leverage data to make decisions in a programmatic and reliable way. And once we have that groundwork laid out, we'll be able to build machine learning on top of it as well, obviously. But my day-to-day also includes user research, partnership conversations with other teams, other companies, and it's really all about understanding how people are doing their work in data science and how we can help make it smoother.
Thank you so much for sharing that, Shantana. I'd love to get into just how you guys are doing that as we progress along in the conversation. Let's go to Ronnie. Ronnie, what does a typical day for you look like over at Google AI?
So I think probably even more so for Susan and Santona, who are doing a lot of leading organization stuff. I'm a researcher, and I guess for all of us, there's probably not a typical day. There's always new tools to learn, new tasks to take care of, and just new things to learn, because oftentimes there's an end goal, like a long-term goal in mind, and you do what you need to get there. So yeah, for me, it's reading papers, it's experimenting with different algorithms. A lot of that is writing the code, but also probably another half of that is looking at the results after you run it, and that's where I use Comet and other ML ops tools very often. So I spend a lot of time staring at those charts, looking at those hyperparameters that I saved, and making decisions from there for the next step.
I'm excited to dig into just how you do that. So we will be getting into that shortly. And by the way, those of you tuning in on LinkedIn, those of you tuning in on YouTube, and even here in the chat, if you guys got questions on anything, please go ahead and feel free to drop those questions. Susan, let's go to you. Let's hear what a typical day in the life of Susan is like.
Yeah, I think at work, there's not a very typical day. Seems every week and every month is a bit different. A huge part of my responsibility is to grow and enable and multiply the team around me. So I guess since I've joined, I've brought into the team more expertise in the data science org, in particular about Docker, Kubernetes, or other things that are MLOps-y, but then they enable the data scientists to be able to run and experiment and improve a lot of our machine learning models in production, because it is very important for our models to be constantly improving, because increasing the accuracy of that can increase the effectiveness of how we're deploying capital to the entrepreneurs and the founders who sign up with Clearco. So that is a flow that basically everyone that has done business or has signed up for us goes through, that this ML portion is touching every single one of our users. So it's really important for us to continuously improve it. So enabling the team to do that with experimentation, using other types of orchestration. We currently use a lot of Kubeflow, which I've brought into the team. And it is with needing to experiment and improve on this core piece of the product. But we are also exploring many other things. It's also a trial and error process as the team continues to grow.
Thanks so much for sharing that, Susan. Yeah, like designing, building, operating machine learning systems it's a lot of hard work. It's a lot of moving pieces, and I'm curious how how do you spread that load out across your team? Whether it's in your current role or maybe in previous roles, or just some best practices for that. Is it typically just one lone kind of person working on just a model end to end, or is it like a bunch of people collaborating, pair coding? How's that kind of spread out on your teams or previous teams that you've worked on? Shantana, we'll start with you, then go to Ronnie and Susan.
Sure. Because we don't have a machine learning product or platform per se, for us, it's not about building and supporting machine learning systems or services at scale. So at least for now, when we write machine learning pipelines, we typically own it end to end individually. And that includes some data engineering work, some product management, even some visualization and delivery work. And that's not to say we don't have good support. The handful of us on the team that are machine learning focused definitely discuss and review each other's work. But I think I'm more excited to hear how Susan and Ronnie do it on their teams.
Yeah, definitely. Let's go to Ronnie and hear what that's like. I imagine it's probably a little bit different working in research as opposed to maybe deploying stuff into production. Ronnie, how do you manage that? Like, is the research that you're doing, is it being deployed to production? Is it just stuff that you're working on solo? How does your team collaborate and spread that load?
Yeah, the current team I'm on in Google Research is a research team, but it's the speech team. So we do occasionally want to roll out all the good things we found in the research, all the improvements into production. But overall, the culture is an academic group, similar to the previous places I've been, doing my PhD or at the University of Maryland. And I think, yeah, it is hard work. You could, but to have more impact, you want to spread the load and work in a team to have more impact. So I think in my type of environments where you have long-term goals, not like quick product cycles, and where it's a laissez-faire system, everyone kind of works on what they're interested in. The challenge is to motivate others to work on and work with you on that. And I think part of that is allowing people to start with you, like at the early stages of the project. So it doesn't feel like you're just telling them to do some task for you. They can have co-ownership, and also giving them a part of the problem that is challenging and not having counterintuitively not having a clear solution for them to implement, so that they can think about it themselves and come up with something that you may not have thought of and is very innovative and rewarding in that way. So that's one lesson I've learned. Yeah, I'll leave it with that for now.
Thank you, Ronnie. Yeah, let's go to Susan. Talk to us about how your team is working on building and developing some of these machine learning models that you guys are deploying into production.
Yeah, so I would say the data scientists are able to focus on what data scientists are good at in general, which is building the models and doing the analysis and scoping out and sizing the impacts of these models. We've recently brought on more folks in the MLOps team in our organization, whereas I guess before there wasn't such a dedicated team. And it was a huge part of what I had worked on to help speak to the overall engineering team on what needed to be done, because it's not necessarily reasonable to expect like data scientists to also do all those other things that, let's say, a MLOps engineer or also a software engineer is doing. So a lot of us had done some work, and I think it's good for data scientists to understand some of that stuff, understand a little bit of Kubernetes, understand Docker. That helps a lot with our role, but again, it's like structuring the team so that people can work on what their superpower is, and then getting, let's say, ML engineers on board, and then they can focus on what their superpower is and like enabling everyone. So that's how our team has grown into collaborating and like spreading the load.
Thanks so much for sharing that, Susan. We've got a great question coming in from one of our audience members here in Zoom, from Marissa. So she's curious about what kind of support roles each of you have on your teams to keep your data scientists and machine learning engineers and developers heads down, focusing on their areas of expertise and not distracted by things like writing Jira tickets, managing client customer expectations, and so on. I think that's a very good question. Very interesting. So if any of you would like to jump first, or we could just go to Shantana first and then maybe Ronnie and Susan, if you guys want to maintain that order, happy to do that. But
I actually really enjoy all of those additional, or adjacent parts of the data science pipelines and projects. So I personally love being involved in setting the SLAs or understanding what the client's needs are, or whoever is going to be the user. And it could be an internal user as well, and working with them and iteratively figuring out the solution. Yeah. So for me, it's less about getting support on those things. Although I will say certainly having a product manager helps. It helps to have the big picture and come back to the big picture every so often if you're especially down in the weeds.
Ronny, let's go to you on this one.
Yeah, it's a great question. And an important question. I think that I'm also, like Santana, tempted oftentimes to get involved in like all the weeds of other things too, of the engineering, and not just focus on the research, not just be heads down. But I think that's probably not the best use of my time. And one thing my manager does well is establish clear boundaries between what's my job and what's not, so that I can stay focused on the research and the modeling while we let the MLOps and the engineers do their job, which is to build the infrastructure for production and for training models. And I think one thing that's important, I think, to allow that to happen is to have clear contracts between the different roles. So for example, like clear owners of the infrastructure that serves the models and clear owners of the models themselves. And so that way, when there is a bug in production or in pre-production, who's responsible for fixing that. We don't have it perfect, but that's something we're working on. I think, like defining which parts of the code each person is responsible for, and writing the code in such a way that is very clear. I think oftentimes productivity lags when there's an error and it's not clear who's responsible for it, and then it just drags on until somebody volunteers. Yeah. And I think that factors into your design. And
Oh no, go for it. Sorry, I was just gonna ask how big your team was.
Oh yeah, I was just gonna say it can be, the contract can be made by design, by the way the code is designed, but it can also be by assigning, like by having a culture where people are owners of certain things. The team size is pretty large. The one that I'm on now is probably around 200 or so. Yeah. Wow. So a lot of people using the same tools, a lot of researchers and data scientists. And so, yeah, all the more important to have these clear contracts as we scale.
Awesome. Thank you so much for sharing that. 200 people on a team, that's massive. I guess when you're at Google scale, that's probably, not uncommon for a team to be that large. Susan, how about you? What kind of support roles does your team have that keeps your data scientists and machine learning engineers heads down, focusing on the area of expertise and not being distracted?
Yeah, I think that's a really good question. Like right now, we don't have dedicated PMs, but whether it's product or project, but our managers and leadership are responsible for setting out stuff like roadmaps and scoping out tickets as well, in collaboration with the senior ICs, as well as junior ICs are responsible for thinking about some of the more detailed scopes. But I would say that before, when I worked at a larger org with a dedicated PM, that there was definitely some overhead that was lifted off of our shoulders, which was helpful. I don't mind doing some of it, but it's more about finding a big balance or a good balance. If this time is really eating into my IC time or my coding time, then there's probably a problem. Yeah, but if there's like some amount of time to doing it, and then because I understand better than, let's say, someone who's not on this project specifically, there are places where I can fill in more of the details in collaboration with my manager. So I think that's good, and I feel supported in that regard. But then it's still about maintaining a good balance. And then I think also on my front, being proactive about the ratio of time that I'm spending on each task. So it is up to me in this organization to like look at how much time I'm spending. And then I think at a larger org, those guardrails and kind of support rails were already in place. So I didn't have to think as much about that. I would say that the data science focused org is like roughly 10 folks, but then there's like the data org, which it depends on what I'm including. And there's also the engineering org, which is like 50 to 60, probably more now. Yeah, but because we collaborate a lot, I think it's hard for me to not include those people because there are projects I worked on which had, let's say, like an infrastructure software engineer, something like that, working on it closely together as well.
Awesome. Thank you. Thanks so much for sharing that. So yeah, machine learning is really, I think, a iterative discipline by nature. We're sometimes taking a few steps backward to go a lot more forward. What are some best practices that you could share around experiments, or maybe how does your company view experimentation? Either or, yeah, like, how do you manage like this iterative process, and how do you manage like staying on track and not getting lost in the weeds and trying to do this and then trying to do that? Let's go to Shantana and hear how you handle that.
Sure. We're very pro experimentation, and we do experimentation because it's a very common machine learning paradigm, right? It's hard to find any machine learning use case that doesn't involve some degree of experimentation. As curators of this tool based on Airflow, it's important for us to embody those personas and demonstrate what orchestration looks like when you're writing experimentation pipelines. And by doing the experimentation, I'm able to showcase different tools and different integrations between tools and how they can work together to bring out different strengths. I will say, I think it's important to note that there's the machine learning experimentation, right? And then there is product experimentation. So it's A/B testing. And I think those are a little bit different. And then I'd love to get Ronny and Susan's thoughts on that as well. But it's very important to be able to write those experimentation engines as a self-contained thing, such that the inputs is what you're giving it to say, this is the experiment I want to run, rather than writing the whole experiment pipeline over and over again. So that's one thing that definitely helps.
Yeah, I'm curious about that too. My background, is as a statistician, worked in clinical trials for a number of years, and it was very much that product A/B testing, experimental design, randomized control trials type of thing, and it's really different in machine learning. So I'm interested to see how you guys handle that over at Google, Ronny, and then we'll go to Susan.
I think one thing that Santana I think said was it's important to make sure that what's being run is very clear instead of like little changes in the code. So I think one thing I would say is, yeah, it's very important to expose both of the inputs, the parameters that's going into a certain model run, and also to expose as many metrics of what's going on in that run as possible, because otherwise these machine learning pipelines are often complex and huge. So you just get the outputs, whatever those outputs are. So it's important to expose as much of those outputs, like maybe little diagnostics of different places in the system, how many evaluations of this function were run, stuff like that, and to save those out. And I think for small scale experiments, if you're running just a few at a time and it only takes 10 minutes or something to run it, then it's fine to just use whatever tooling you want. But I think when you're running hundreds of experiments and it takes 2 days for each experiment and you're going to forget about it, it's really important to have a good tool. And I think Comet really helped me in that way, just to organize, to expose those inputs, those parameters that you're sending in, the learning rates, etc., and also the output, the error rates, and put it like on a web page, a static URL, and be able to compare different experiments with each other. That, I think that's very helpful for, and oftentimes you need a special MLOps tool like Comet for that.
Yeah, definitely. I remember when I was first getting started, I used to just use a notebook. I'd write everything in my notebook, all the different hyperparameters and then the result. And then I got a little bit more sophisticated, moved on to a spreadsheet and started putting stuff into a spreadsheet. And then found out that people actually make tools for this stuff that makes life so much easier, like Comet, for example. Susan, let's go.
That's exactly my experience too.
Yeah.
That's exactly my progression. I used to just record things in a notebook or text file, then move to the spreadsheet, and I was like, there's got to be a better way.
Yeah, there's still some Post-its on the edges of my monitors here, like with some experimental inputs and stuff. Susan, let's go to you.
Yeah, and I definitely have also used like text files and spreadsheets, I think, before. But yeah, I think for us, it's also important to record like inputs as well as outputs. And I think an important part of experimentation for us is ensuring that there are metrics in place, and then just more, of course, like more data that's relevant about just the truth that's happening before and after the experiment. As a growing company, or I guess like when companies are growing their tech team, there's definitely sometimes there's some data that's not being tracked. I think our org has done a really good job of, I've seen it grow like in a really upward trajectory of, hey, what's available now and what are the things that are being tracked? And I think it's just looking at that really targeted improvement of the data that is relevant for data science and machine learning experiments that are being tracked to keep being improved. So I guess like for any, I think there was someone in the audience that seemed to come from a growing startup. It's like really being able to focus on what's relevant for the data science and machine learning experiments, the metrics and how we calculate those metrics, and having that data be exposed, persisted, or tracked in some shape or form. Yeah, that's really helped our org.
Thank you very much. And just a reminder for those of you watching on LinkedIn, on YouTube, and here in the room, if you guys got questions on anything that we've discussed so far, please feel free to ask your questions. They're absolutely welcome. Thank you guys for sharing your insight into how you guys are managing experiments. But I'm wondering, so can you share some best practices for maybe one of the most confusing parts for me when I first started out was this like hyperparameter optimization thing. It was like, how am I supposed to go about approaching that? Do I just pick random numbers and just let it go? Or is there a method to this madness of trying to find the right hyperparameters? What are some best practices or life hacks you can share with us? So let's go to Shantana first.
Sure. I think Ronny and Susan have already pointed out a few of these. So I think documentation for starters, tracking, monitoring. For me, tracking and monitoring are a bit different. So tracking is where you're making sure you're capturing it and it goes and lives somewhere, persists somewhere, and the monitoring is actually visualizing it and then watching how it progresses over time. Yeah, so those are a few. And then if it's an experiment that you're going to take some action based on, then having that, making it easy to take that action. So there's the experiment pipeline, and then there's the now this happens as a result of this. And I think that the better those two are tied, the better it is.
Ronny, let's hear some best practices from you.
Yeah, so regarding hyperparameters, there's usually two things you're trying to do. You're trying to just optimize the absolute performance of your system. For that, you can just, you have to understand the hyperparameters, and that's case by case, but I found actually the Bayesian optimization tools out there. I know Comet has one. I think you guys call it meta learning, but there's other companies that do this. They're actually pretty good, and they can scale to a lot of hyperparameters. So if you have the compute, you can just automate that process, and it usually finds the optima pretty quickly. The other oftentimes case with hyperparameters is you're just trying to find if like a change you made of one hyperparameter, how that affects the result. If you just want to optimize one hyperparameter, in that case, you should just do a controlled experiment where you fix the other hyperparameters to some reasonable values and sweep that one parameter. And oftentimes what I find is the covariance of different hyperparameters isn't that large. You could just optimize each hyperparameter independently and take those all together, and it leads to often a pretty optimal system. Yeah, that's how I deal with hyperparameters.
Thanks for sharing that. Yeah, I found that very interesting, looking at the different, like just perturbing one particular hyperparameter and just seeing if you wiggle this thing, what impact does it have on the output. That's an interesting thing to look at, the covariance between different hyperparameters and how that impacts the output. One of the colleagues here at Comet, Drew, did a not experiment, but I guess exploration of how various hyperparameters interact using XGBoost. I'm sure we could dig that link up and share it on LinkedIn here and here in the chat as well. Susan, let's hear from you.
Yeah, like really good points from Santana and Ronny. So I think for my experience, sometimes there's not always like infinite compute depending on, I guess, like for a smaller size company, there's definitely, it's kind of, oh, you can let it run for 2 days or 5 days, probably 2 days being a bit much, but it's kind of, if there's some way for us to earlier in the process narrow down what kind of parameters we want to be, let's say just using some sort of grid search, it's possible for us to just, let's say, run, like tweak them at different intervals and then see which section or which hyperparameter we want to focus on, and then just letting the grid search run specifically on that one. So this is more because we can't just set it and forget it and then run on everything and forget about it, because yeah, it's definitely kind of a smaller company thing where it needs a little bit of optimization and consideration there. But otherwise, I guess like the other techniques are pretty similar to what other folks have mentioned.
Thanks so much. That's really valuable. Thank you for sharing all that wonderful information. I'm wondering if you guys could share a war story, maybe when hyperparameter tuning went wrong, either from a personal experience or something that you might have heard from a news or from a friend or something like that. That'd be interesting to hear about. And Shantana, let's go to you, and then Ronnie, Susan, if you guys have anything, let me know. I'd love to hear some more stories.
I don't have a horror story on hyperparameter optimization going wrong, but as others were talking about parameter tuning, I remembered this example, or this one time when this was back when I was at CERN, and we were trying to determine the parameters for this model, and two of the parameters were very highly correlated, right? So they were very much dependent on each other, and the reason we have to stick with that model is beyond, like, we had to stick with that model because all this similar analyses have been done with that model. What we ended up doing still was a mix of what Ronny and Susan described. Basically, we know that these two parameters are highly correlated. So we find the 2D space where they make sense. And then we hold one and move the other, and then iteratively hold the other and move this one in a smaller space so that we can iteratively get to a optimum. The thing is that there can be other optima as well, and that's okay.
Thanks so much for sharing that. By the way, yes, Shantana did work at CERN, and there's a IMAX movie that features her called Secrets of the Universe. Go check that out. It's yet to come to a theater near me, but I'm excited to check that out as soon as I can. Secrets of the Universe. Check that out. Ronnie, let's...
Yeah, I don't have any hyperparameter horror stories or war stories because it's usually I work in pretty low severity situations where if you mess up, you just try again. There's not being rolled out to the real world. But I think maybe just changing this question a little bit, I think just optimization for a single objective oftentimes can lead to horror stories, unintended consequences. I think we've all heard of some of the horror stories in the news on social media and stuff where a machine learning system optimized for one metric and had unintended consequences. Yeah, other than hyperparameter tuning, maybe the objective function also needs to be looked at when you're doing hyperparameter tuning as well as just modeling.
It's a very interesting and important consideration is selecting the right function to optimize. Any high-level tips on how to go about that in a more intelligent manner?
Yeah, I'm not an expert in this by any means. I've mostly worked on problems where the single objective is enough, like in image recognition or speech recognition, but not always, but in certain toy research problems it is. Yeah, so there's a decent amount of research out there on fairness and bias, but yeah, I'll just leave it at that for now.
Yeah,
I don't have specific experience or comments on it. Yeah,
that's great. That gives us some vocabulary to go look that up, and maybe you might dig into that in a future office hour session. Thank you so much, Ronnie. Susan, let's hear.
I guess I don't have a particular major horror story in production, but I think there were some interesting problems I worked on when I was doing work in reinforcement learning, and the previous role is thinking about how the model or the reinforcement learning agent would behave. So for example, if the agent is supposed to increase some sort of take rate, for example, it might accidentally learn. So there could be behaviors that the agent could select. So for example, giving a $20 discount or $40 discount with this, or a $30 discount with some other thing. And it could be, I guess, when you think about it, it's obvious, but it could just learn to just give the biggest discount all the time. And that might not necessarily be the best for the business. So thinking about how we have to use more of a function form to calculate, let's say, the present expected, present value of what these customers being retained down the road. Maybe they'll take it and they'll cancel, or they'll take it and stay with us for 3 years. And boiling that down to a metric that actually makes sense for us, because it could be possible we're willing to give them the biggest discount all the time if they're staying with us, but we need to quantitatively know that. But it's possible that the agent will just go wild and just be hey, you get a discount, and then the customer cancels, and that's not good. So it hasn't caused like any horror story because we monitor, and Shantana has mentioned like good stuff about monitoring and how that differs sometimes from, let's say, tracking and what's necessary and how that's helpful. But yeah, we had monitoring, so like nothing really wild happened, but it's good to think about those things.
That's a very interesting use case for reinforcement learning. Admittedly, reinforcement learning is not like an area that I've spent a lot of time studying or researching, but the use of reinforcement learning to optimize the coupons that somebody gets, that's really fascinating and like a real tangible, real world example of that. Do you have a favorite framework or favorite library for reinforcement learning that if people are interested in exploring it more, maybe they can go look up some tutorials?
So previously I've used TF agents, so TensorFlow agents, but then I think in recent years, and I haven't personally used this in production, but just like have learned about it through different use cases that I have been involved with, is WoPow Rabbit. It's hard to say, but I think it's like now developed with Microsoft. Don't quote me on this because I don't have the page up. Yeah, but it's like WoPow, like VOWPAL, and then Wabbit, I think is like WABBIT. Yeah, it's like a non-intuitive spelling, but that's one of the more recent packages I've came across.
Yes, that's one I've heard of as well. There's another one that's I think it's called Ray. I think Comet is currently working on an integration with Ray as well. So we'll be keep an eye out for that in the near future. So something that brought up that this concept of monitoring. It was one thing to monitor the model as it's training, while it's training, to see how it performs, but if it's different once the model has been shipped and deployed. So I'm wondering if you could share some best practices for monitoring models once they've been deployed into production. How are you guys making sure that it's behaving as you trained it to behave, and what are some things that you look for once it's been deployed? Let's go to Shantana.
Yeah, I think if you've done the best practice stuff that we've been mentioning so far with experiment design and sort of pipeline design, then you're already in a good place to be able to monitor your models in production. The tracking and monitoring obviously has to continue, and everything has to be versioned well, so that, and not just the model rate, everything has the snapshot of what was the code on this day, what did the model look like, what did the data look like. It's only when you have a snapshot of all of those things that you can figure out what caused something. So being able to do that forensic analysis and creating the telemetry to facilitate that is extremely important. And then I think Ronny alluded to this before too, is alerting, right? Proper alerting and being able to respond quickly to those alerts and knowing who's responsible for it and jumping on it is extremely important as well.
Thank you so much, Shantana. Ronny, let's jump to you. I know you touched on this a little bit, but I'd love to dig a little bit deeper.
Yeah, everything Shantana said. I don't personally do much of the monitoring of launched models in production, but I think one thing that I deal with a lot is if we want to have a model that, say, I trained during the research and want to get it launched, we put it through this tool that I can't change, that simulates the real world, like launched conditions. It runs the entire launch pipeline and evaluates my model on like fresh and like very realistic data that will come in through the traffic. So that way we can get gold standard, like trustable numbers on how well this model compares to a previous model. And there's another tool that I use, which is I compare my research model to the current production model, and on current traffic, run it for a couple hours, and then gather like maybe 500 examples and have raters, like human transcribers, rate, did the experiment model do better, or did the old production model do better on the same exact output of the model? And we call it a side-by-side, and that way it's pretty, you get a pretty clear answer on whether your model did better or not, your candidate launch model.
That's interesting. Oh, sorry, Shantana, go for it.
I'm just going to say, sometimes it's called a champion challenger framework as well.
Yeah, I was going to say, I've heard it that deploying, I guess it's different than a shadow deployment, because in the shadow model, you're actually deploying it on live data. But here you're saying it's not actual live data, it's simulated kind of live data. So are you taking, let's say you've got X number of features, and then you say, okay, feature X1 has this statistical distribution, so we'll just randomly sample or just sample from that distribution and do that for each one of the features and then fit the model to this synthetic data set? How does that work? If you could share that detail. Yeah, Ronny, yeah.
So I think you mentioned synthetic data. So we don't do any like tests on synthetic data usually. Yeah. What was the other part of the question? Sorry, I missed it.
Oh no, it was just it sounded like a shadow model type of deployment when you're deploying that model on production-like environment. So I just drawn some parallels between those type of methodologies.
Yeah, I think it's very similar to what you and Shantana just described. What I said.
Thank you very much, Ronny. Let's hear from Susan on this. I know we're running a little bit short on time, so I guess we'll hear from Susan on this and see if there's questions coming in from the audience, either on LinkedIn, on YouTube, or here in the chat. This is your opportunity to get some last minute questions in. But yeah, let's hear from you, Susan.
Yeah, what both Shantana and Ronny have said are pretty relatable. Like we do, let's say, back testing and like simulating before going to prod just to see if the performance could beat out, let's say, previous like champion models. But then I guess after it goes to prod for monitoring, I guess like dashboards built on top of the model outputs that are being persisted. So then we can see how they're performing. At a previous role, we had a really good suite of dashboards that were in a really centralized place, and you could go and see all the models and they're all plotted out together. So you could see how they were improving or how their performance, not improved in production by itself, but if they've declined or anything. So I think that was a really good thing that like I was not responsible for building that at the previous org, but I'm really grateful for folks that led that initiative to do that because it was a really clear and useful dashboard and exposed also the model's performance to other stakeholders.
Thank you very much. I know we're running up against the clock here, but I'm wondering if you guys have just a few more minutes, if we're able to go maybe a few minutes past the hour. I'd love to just pick your brains. We're still super early in 2022 right now. It's February 2022. But what are some industry trends that you noticed in 2021 with respect to machine learning model deployment development that you'd wish that you'd liked rather to see gain more traction? And maybe what are some trends that you wish would just stop? So let's start with Shantana, then we'll go to Ronny and Susan.
I think it's a little early to talk about 2021, and trends don't often follow that annual cycle. But one of the recent trends that I think has gone down now, and I hope goes away, is this idea of overpopularity of no code and end-to-end automation and solutions in the machine learning space, right? Because you can't really abstract all of it away or automate all of it away without sacrificing the quality of the work or the product. Trend that I want for to stay, and I think it will, is treating data as a product across the organization, which increases the quality, reliability of the data, and more people are invested in doing the QA and the annotations and so on and so forth. And then everything that you build on top of that it also benefits from that rich data.
Thank you so much, Shantana. Let's hear from Ronny.
Yeah, I think probably Shantana and Susan have more to add on this. I don't have too much to add on this question because I use mostly internal tools and I'm not as exposed to the open source community anymore as I was when I was in a university. So yeah, maybe I just won't waste the final minutes and let Susan go.
Yeah, definitely. No problem. I appreciate that, Ronny. Thank you. So Susan, let's hear from you. Question was all about, we're super early 2022. What are some industry trends that you noticed in 2021 with respect to machine learning model development and deployment that you want to see gain more traction, and some that you would wish would just stop?
I guess maybe this isn't like a trend per se, but I think in recent years, and this isn't isolated to last year and this year only, but just I guess the roles in machine learning and data science are becoming more specialized, but then in smaller companies, they could be more, people could wear multiple hats. But then I guess in larger and larger companies, you see the roles becoming increasingly specialized. So I think I'm interested and curious to see how that plays out, if it just becomes more specialized or if it like has reached an optimum and then we are at this level of specialization that we are at now and it doesn't specialize more past that. Yeah, there's something I was like curious to see, but I don't have a particular kind of like opinion for or against because it's a different requirement in different size companies and based on what that company is building or focusing on.
Awesome. Thank you so much. Opening it up here to the chat here and to the folks watching on LinkedIn. I've had a great discussion here. If you guys got any questions, please do let us know. I'm happy to take questions from the audience. And if not, maybe I can squeeze in one more question. I know I said that was the last question, but I'd love to just get one more if you guys don't mind. I'm curious, what advice would you share with up and coming team leads or up and coming principal data scientist or up and coming research scientist that you wish someone had given you on your way up? Asking for a friend. Let's go to
Yeah, I don't feel super authorized or super in the right place to answer that question, especially for a team lead. But for a researcher or someone who's perhaps transitioning from research to industry, I will say the business context. I think this is said over and rightfully so. Business context is extremely important. Acceptable versus a perfect model is extremely important. And then something that we've been chatting about in this hour as well is performance metrics are subject. So understanding that you can max out on accuracy or whatever, the model doesn't serve your business's interest. So it doesn't matter. So keeping all that in mind, and Susan gave an example earlier about optimizing one metric while it didn't really capture what needed to be done. And often we don't have that context because the stakeholders or the requester of something comes in and say, oh, I want to see this optimized, or I want to see the 1% up, whatever in revenue or something, but you don't have the full context. So I think searching for that full context is extremely important as well.
Thank you so much, Shantana. Ronny, let's go to you.
My advice would be more for researchers, though it may be applicable to managers. I think, like we said, machine learning is very experimental science, and it's oftentimes hard to decide what method will work best. My kind of heuristic is it used to be what's the coolest and what can result in a research paper and potentially make the biggest gains. I think now it's shifting more to which of these methods will be the quickest to implement right now and give me some answers and guide the next iterative decision. So I think speed of execution in an environment of uncertainty, like machine learning often is, a very empirical field, the speed of execution and iteration is very important. Yeah.
Thank you so much, Ronny. Susan, let's hear from you.
Yeah, both what Shantana and Ronny have said are really relatable, and I think that's really good advice. I think for me, my advice for someone who's probably like rising up in their career is, I think earlier in my career, it was underrated a bit, like communication skills and being able to boil down ML concepts to not even just stakeholders, but even teammates who aren't working on the same project. It's really important to give that context and have that storytelling skills. And I would recommend that to everyone. Like that's up and coming, new grad, like anyone. Yeah, definitely overlooked it, but it's definitely improved my career so much. Like even at my current role, once I was going to present and the CEO was basically like, oh, I'm looking forward to another Susan presentation. So it's kind of like associating me with like good communication and good presentation. So I think that's like really helped me in my career. Recommend it.
Thank you so much for sharing that, Susan. Yeah, and Susan's definitely an awesome storyteller. Like I'm a huge fan of her blog and her writing style. If you guys haven't got a chance to check that out, please do. SusanShu.com, I believe. One of my favorite writers in data science, mostly because she writes about stuff that I like to read about. So thank you so much, Susan. So guys, that's it for today. Thank you so much for joining us. Next week, we've got another awesome panel discussion. We've got Tiffany Fabianic, who is a enterprise data and AI engagement lead over at AstraZeneca. She's going to be joining us next Wednesday. We've got an in-house expert as well, Dr. Douglas Blank, who's the head of research at Comet. We're going to be talking more about experiment management and also a bent towards reproducibility in data science and machine learning. The panelists today, you guys are more than welcome to join us again next week. I'd love to have you guys again. If you guys could manage that in your schedule, you're more than welcome to join us. Same time, same link as next week. So I'm excited for that. And hopefully you guys at home can join us as well. It's going to be great. Again, Tiffany Fabianic, Enterprise Data and AI Engagement Lead over at AstraZeneca. We're going to be talking more about experiment management, but then digging a little bit deeper on reproducibility and the importance of reproducibility in machine learning. Plus, we'll have a in-house Comet expert, Doug Blank, head of research. Thank you guys so much for joining us today. I hope you guys gained a lot from this presentation. I know I did. So take care. Have a good rest of the week. Have a good rest of the day. Remember, my friends, you've got one life on this planet. Why not try to do something big? Cheers, everyone.